Hi, this is Group P1, and our project is a CNC conversion kit for a standard drill press. It is known that CNC machines can cost up to $30,000. For startup companies and hobbies, these prices can be out of reach. The solution? To design a universal CNC kit for drill press machines. A kit under $1,000 can be a good option for targeted customers. Budget to produce this product is limited. With that in mind, can this kit be good for tough materials such as metals? Will it have the same optimal resolution when milling? These are some constraints to consider.
So here we have the work table device, the collet system, and the electronics, which are all things that compose the CNC conversion kit. So here's the work table. We first thought about designing and manufacturing the table entirely on our own. We were going to use the wide, solid steel struts to construct our X and Y axis frame with track guide rails and small bearing carriages. But instead, we found a work table from Amazon called Yuzogu. Although this work table was within our budget, it did not satisfy our design goals. This table had 4 fitted carriages on each axis that moved along a guide rail, which was not strong enough to hold its position when shear and torsional forces were applied. We chose a different table called a Moform milling work table as our final design. This table had dovetail joints, which are used a lot in work tables to provide resistance from being pulled apart, as these joints are held together under tensile strength. This table had an Acme lead screw, which will be replaced with a ball screw, as it will allow us to get rid of backlash in the work table.
This is the vise. The initial design was this $20 vise from Harbor Freight. It was originally considered because of its simplicity and within our budget limit. However, Dr. Pellegrini suggested that this particular vise uses a point load system, which does not provide enough distributive force along the jaw moving axis. Later, by constantly searching for a better solution, we found the following vise table. Looking at the exploded view shown, this vice table contains a vice nut shown in figure 3. This vice nut is capable of guiding a movable jaw on the rail with the force evenly distributed along the entire surface of the clamp, which eliminates wobble and strengthens the hold.
This is our collet system. In order to convert a drill press into a CNC milling machine, the system must handle axial, transfer, and torsional load to work properly. Unlike a regular milling machine, a drill press can only take axial stress, so a solution to this issue was to replace a drill truck with a collet holder. Initial thoughts of including a keyed collet like in milling machines were discarded due to the fact that a drawbar is needed for such a configuration, and a drill press is not suited for that. Another option was to use a collet holder along with direct Loctite to keep it in the quill of the drill press, but this is too permanent of a solution and would alter the structure of the drill press. With the help of Dr. Basili and Mr. Simonovich, an ERE collet system design area was introduced, allowing the drill press to take different types of loads without altering the machine. Other benefits are reduced vibration, higher RPMs permitted, and increased accuracy of work. The ER20 collet was chosen for this project because the diameter size would fit into the M2 taper-like holder.
So now let's take a look at the electrical subsystem. For preliminary design, the idea was to use Raspberry Pi or Arduino connected to a breakout board that would connect to a computer with Universal G-Code Sender as a platform software. When looking at options, a kit package was found for $148 that contains stepper motors, drivers, and a breakout board. After consulting with Dr. Pellegrini, we realized it was of poor quality. A gear reducer was still needed as the resolution of the motors was unknown and the software was specific to the kit. After finding good reviews for some drivers, we chose to go with a microstepper driver that runs on Mac 4 and Mastercam, or Mastercam G-Code software, which is a more popular and compacted platform. The NEMA 23 motor takes 200 step signals to reach 1 revolution of movement. 1 revolution is equivalent to 2 millimeters of axial movement on the work table. Calculating a resolution of 3.4 thousandths of an inch, the microstepper drivers can further raise the resolution to twice the stepper motor capabilities, thus fixing this issue, which gives us the final design.
The work we have done so far of the project consists coming up with preliminary designs for the mechanical and electrical subsystems. We have compiled a purchase list needed to get this project prototyped, and we've designed 3D models in SolidWorks of our project. This work we will expect to complete next semester, and we will be running stress and structural analysis on our system, test our assembly and ANSYS, revise and make any changes to design if needed, and ultimately finalize our project. Here we show our fall 2020 progress in a Gantt chart. And here's our spring 2021 progress that we will be working on.
Thank you.
Thank you.
Thank you.